Hey guys, it's David from 3D Make It, and today we're going to be talking about temperature towers. Let's go. Hey guys, so if you're here, you're wondering what a temperature tower is, maybe what it's for even, and how to do it. Well, simply put, this is a temperature tower. A temperature tower is a test print that lets you decide what the best temperature your filament can print at is. They're useful for if you are switching between different kinds of filaments or sometimes even between brands. And I'll go into that in a second. But the temperature tower we're going to be using today is called Parameterized Smart Compact Temperature Tower. I'll leave the Thingiverse link below. It'll flash up on the screen here. It's important to note that once you get this print off the printer, you do not clean it up. You take it as it is, and it is a diagnostic tool. So that being said, let's jump in and I'm going to show you how to get this at a Thingiverse into your slicer, either Prusa Slicer or Cura. Over on Thingiverse, the temperature tower I like to use is called Parameterized Smart Compact Temperature Calibration Tower. It's a mouthful, but it's a really nice model. And there's several reasons why I like it, and I'll go on to show you a little bit more too as we go along. But this tower by default goes from 225, so 225 degrees up to 175, which I think is a little cool. Your filament shouldn't print at 175 in a good situation. If it is, it's cheap filament, throw it away. Or if you're printing some of the wax stuff, I'll give you that. It could be good filament. But if you're printing below 200, you might want to look at the quality of your filament. The other reason I like this tower particularly is if we scoot on over to the file section, there is a file. So this guy here, this parameterized STT, it is the full tower. That's the one you see in the Thingiverse picture. It will give you the model for 225 to 175. But this is my favorite thing about the model. So these three things. So there's an SCAD file, and then there's a brick section for the SCAD. And then there's a smart temperature tower stand, which just stands it off the bed a little bit, which kind of complicates things, but it's not too bad. But the idea of the temperature tower is basically that when you print it, the printer changes to the temperatures listed on the front of the tower. So we can see here at the bottom of my tower, starting at 225. And as I go up, it's getting hotter or cooler and cooler and cooler. Now you need to start hot to cold, because if you start it at a temperature that your printer can't extrude at, everything will fail on top of it. Now, this particular tower does a really good job with bridging. So you can see that there's a cooling bridge that takes part. So you'll be able to see if the filament is printing warm enough to bridge or too hot, too cold. It has these nice little spikes to show you the points and how fine of detail and the cooling effect it's going to have on those points. The stringing test happens between these gaps. So that's why it's very important that you don't clean these models up, because you're not actually going to learn anything from them if you clean all the stringing off. Now, when I showed you the example, my example only went up to about 210 degrees. And that's because I know for a fact the filament I'm printing with is between those ranges. So I'm going to download all these files. I suggest you do too. And then we're going to get right into the nitty gritty of how to do it. So just go ahead, download all these files, and I'll see you on the next screen. Hey guys, David on the next screen here. So the next thing we're going to download is OpenSCAD, because I am going to show you a little bit about how to customize this. There are a few ways to do it, but OpenSCAD exists to make this quick and easy. So head over to Google, grab OpenSCAD in your search, and then hit downloads. From here, we can just scroll down, and then depending on your operating system, obviously you're going to pick the one for you. I'm 64-bit Windows, so I will grab the 64-bit window installer and just save that. I'm going to run the installer here. There's nothing magical about it. It's probably one of the most boring installers on the planet. If you do see the UAC window, just click yes. It's just making sure you want to actually install this because your computer doesn't quite trust it. So literally this installer is you hit install and you wait a second and then you hit close. That's not even worth a tutorial, but we did it. We got that installed. So the other assumption that I have is that you are going to have Prusa Slicer or Cura, whichever one you want to follow along with. And again, there's chapters down in the link and in the little toolbar there in the video bar, so you can skip to wherever you want. I do want to make a quick point about temperature towers. We talked about a little bit about why, and I want to talk about how many I've printed and when I've actually used them. So this little guy here, I printed for this video, and it's white and it's a little blown out, but you can see it's got a little stringing until it gets to the very top one, which happens to be 210, which is good news because that's what I print my filament at here. And then you can see artifacts on them as they go up and down and more stringing. And I'll talk a little bit about those as we go through, but this is actually the second ever temperature tower I've printed in the 4 years that I've been 3D printing. I like to use calibration models, and I'll tell you why in a second. And when I say calibration, not necessarily benchy, like benchy and Astro Print Rocket, something that exemplifies all of these features at a temperature that I trust for most PLA. So without going too far into it, PLA will print at its hottest when it's in its purest form, meaning the closer you are to a virgin PLA material, the hotter you have to print that filament. If you're printing your filament in the lower range between 190 and say 200 in there, or even 185, your filament is probably not all the way virgin PLA material. It could have some recycled stuff in it. There's nothing wrong with it, but this is where it comes to knowing your brand of filament. So the reason I haven't printed a temperature tower is because I trust the manufacturer. When I buy Protopasta, I expect Protopasta's claim of, using virgin raw material, which they do. It's great filament. When I buy Matter 3D filament, I trust their claim. It's great filament. And I know for a fact I'm going to be printing in the hotter range. Now, I printed a temperature tower to start with the Protopasta filament I have. And then I printed it with this Matter 3D filament. The reason is because those virgin materials, I wasn't quite sure on how pure that HT PLA or the Performance PLA printed. Now, those ones were up over 225. So this really helped me dial it in quickly without failure. Now, if you are printing filament that you trust and know, do you need to print another temperature tower? If you're buying another roll of Hatchbox, CC Tree, whatever you're buying off of Amazon, Amaze 3D, I could go on and on, list is huge. No, you know your filament. If you're having a particular failure or you're noticing some diagnostic things happening, like, hey, this filament is sure stringy, I wonder why, then go ahead and print a tower. It'll help you out. When you're printing a temperature tower, especially like even this little guy, which isn't very big, but if you're printing it, it will take longer to print that tower than it will a calibration item like a benchy. A benchy's 40 minutes, 20 minutes if you push it hard, right? The tower can take up to 2.5 hours if you print the full thing, and it's important to use the print settings you're using. So that's my rant. We'll get on to how to, but I just wanted to let you know that's kind of like the why and when and why I usually don't. But it is a good tool, so let's jump in. We're going to open it in OpenSCAD first. I'm just going to show you how it works, and then we'll bring it into Prusa and then Cura. So let's go. Once you've downloaded the file from Thingiverse, I downloaded all of them in the zip, so I'll just go into the file section, and here they are. You can see that I have an OpenSCAD file. It is very important if you are going to use this SCAD from this model that you need these two smart temperature tower stand fixed and temperature floor. Those need to be in the folder or this won't work. So I'm going to open OpenSCAD. I just double click it. Since it's the first time, it doesn't know, so I'm just going to pick always OpenSCAD files with OpenSCAD. I'm just going to click OK. And we'll wait for that to open up. And we are greeted with a screen that, well, basically looks like this. Now, you can see here that it's generated a temperature tower. And it's actually generated the temperature tower that's on Thingiverse. I just really quickly want to go through a few controls so that you know how to get that image if you don't see it. So over on the left-hand side, there is a preview button, which is also hotkeyed to F5, but it's the square with like the play arrows to the right there. If you hit that, it will generate a preview of the file that you're building. Now, OpenSCAD uses programming logic to build STLs. So the reason you need that two files inside of that folder is because it's using those files to stack, and then the base of the model is the floor. So it's actually calling those in this script. We're not going to get into OpenSCAD too much. I'm just going to show you how to use this to change the size of the tower if you didn't want to go full. So let's say you want to print a quick tower. We can open on the right side here, parameters, and you can see here that it gives us our temperatures. So we have 175 and 225. So 225 is a pretty good top temperature. We don't want to play with this T-step. That's actually giving it the gradients that we want as it's stacking them. So just leave that number alone. But if we wanted our temperature tower to stop at around 200 degrees even, which would save us time, and we know for a fact that our filaments, for the most part, we like to print between 200 and 215, let's say. So I'm going to change that to 200. Now you can see here I changed it on this side and everything has changed. And then it updated my preview as soon as I clicked off just into the gray space. So this preview rendering happens all the time as long as it can. So now I get a model that's a little smaller. It's going to be a little quicker to print. I can then render it. So what I need to do is render this model before I can save it. So if we look on the left-hand side here, there is an STL export button. If I click it, I get this error down here that says, whoops, try rendering it. Press F6. They make it dummy proof. You can press F6 if you want, or the square next to the preview button. So the one right next to it with like the little cursor symbol is the render. So you click that, it will render it. It disappears briefly just because it's actually making the model now. So we're not in quasi preview mode anymore. It's generating that STL. So it's mending the mesh, it's making the triangles, it's putting it all together for us. Once that finishes, we can then click the STL and save it. So you're going to hear the chime, the render will show up now, and we can see that it's ready to go. We can click that STL button in the top left here. It will open the window, and it's literally called parameterized STT, which is what the other one is called, the one we downloaded. I'm going to save it into the same folder, but I'm just going to call it new so we know which one we're dealing with. So we're going to bring both files into Prusa Slicer, and I'm going to show you how the actual temperature tower script works. And that is right, you use a script in Prusa Slicer. You use a script in Cura, but it's a little more GUI based to make it. Now I've written a script that actually does this in Prusa Slicer, so I'll take you there. We'll show you first. So I'm going to open both models in Prusa Slicer just to show you how it looks like. Once we're in Prusa Slicer, we do have to decide which printer we want to use these models on first. So this CR10S for me is just fine. I'm going to use a CR10S. So this is the default Prusa Slicer CR10S profile. I'm going to change it to 0.2 layer heights. This is also important because the script I have that I made for this is in 0.2 increments. So we want to make sure that that script is correct. Next, we're going to bring our towers in. So I'm going to bring both of them in. So I'll just drop those in there. We can see that I have two towers, a short one and a tall one. If you are unsure of what filament you're using or what the actual low temperature is, if you haven't experienced a little bit in that brand or type, do the tall tower. The worst that happens is it starts failing at the lower temperatures, so the higher blocks. Other than that, they will both work. I'm going to delete the small tower. We'll continue the example with the big tower for now. And so we'll hide the small tower, we'll hit A, and that'll take it off the build plate. It actually just moves it off to the side if you're not familiar with what it does. So as soon as you hide it and arrange the models, it moves it off to the side. The next thing we have to do is change the Gcode. And this is where the scripting comes in. So we're going to click the gear beside the printer settings and click Edit Preset. You can also get there if you click the tab along the top here. So that's another option. Once we're in the printer setting tab, we go down to Custom Gcode, which is right here. We're going to go to the Before Layer Change Gcode, and we are going to paste the script that I have put in the description for you. You can paste the whole thing. it will just replace what's there. There's no problem with it. Just so you know what's going on, it puts a label, a name before layer change so you can see where it is in the Gcode. It resets the extruder and then it pastes or posts, I should say, the layer name. So which layer you're on. Now, this code underneath this else if is basically going through, and you can see here, if it's below layer 11.4, it's going to set the temperature to 225. That's what it's doing. So as soon as I go beyond layer 11.4, it actually sets the temperature to 220 until it goes beyond layer 21.4. And then it sets the temperature to 215 and so on and so forth. So as soon as it gets bigger than this number, it moves down to the next line and sets that temperature. I'm going to show you where I got those numbers from because I am sure you're thinking, hey, what? But basically it goes through until the highest possible place it can get on the model, which is the top of the model, and then it ends. So the end if makes sure that nothing happens, and then your normal Gcode finishes the script for you. So let's go back to the platter and we'll slice this model, and I will show you exactly where those crazy numbers come from. So first off, on the on the right hand side here, we can see that we have this layer slider. Boop. We can see there's a number at the very top that says 111.4. If we go into our print settings and look at our custom Gcode, at the very last line of the script, we have, if the last layer is below 111.4, please set the temperature to 175. Again, this is the big tower. So that 111.4 is the top of the model. And once you slice that, you can see all the layers change with this slider. So if I go down and then I want to see where my first layer change actually happens, I'm going to go up, 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 and we want it to bridge. So here's the bridge. And then we're just going to keep going until it starts printing the next part, which is right there. So I'm going to come back. And this will be the next level. So I'm just going to zoom in and I'm going to show you this in really good detail here. So we can see here that if I come up, it does our bridging test and then it starts the next layer. Well, we want it to shift temperatures as it starts the next layer. The reason it's not a big deal that it takes a little bit of time to switch temperatures is because we have about 6 layers before the bridging starts, and that's really where the next test is really important. And it's going to change in time about at the bottom of this cone so that we actually get stringing tests properly as well, which is cool. And so we can see here that this first layer change is 11.4. So I have 11.4 in my sidebar there. And if I look at the printer settings, and I go to my custom Gcode into my before layer script, I can see that the first change happens at 11.4. So anything up to layer 11.4, that's what this less than or equals means. So if it's less than or the same as 11.4, it will be 225. So the very next layer that prints after that will be 220. And we can check till when. That's 21.4. The sweet part about this is after you do 2, you can see the pattern. The first one's a little harder because there's a base. But after that, if we can go up to 21.4 on our slider, so we'll just pull it up to right to 21.4. And I'll just back it out and move it a bit so we can see it. So we're coming up on 21.4 now, 21.4. Did it. And here it is again. So that means you can just add 10 to the number now indefinitely until you get to the very top of this tower. So every one is basically going to be 10 layers and then it switches. So it's easy to do, but the script is kind of tricky. Now, if you wanted to change your layer height, by all means, you could. You would just need to change the script. So if you wanted to do, say, a faster temperature tower, and we were going to go with 0.28, let's slice that tower. And in Prusa, we're just going to go down again, and I want to find where that layer change is. So it's right here. And you can see here, even at a 0.28 layer, this one actually works out. But if you get into weird non-magic numbers, you'll just have to change them. So you can print a temperature tower a little bit quicker by changing the layer height. However, When printing your temperature tower, it is always best to use the settings you want to use in most of your prints. If you are going to be seeing what temperature is best for bridging and you usually print at 0.28 layer heights, do the temperature tower at 0.28 layer heights, because layer height can affect bridging. There's more material hanging across there, so it can sag more. So make sure you're doing your tower at an average speed that you print at, and then make sure that the layer height line. Hey guys, just wanted to mention before we jump into Cura that script is height agnostic of the model, meaning you can make that model the 200 or the 175. That script can go in Prusa, and no matter what, it will work. It'll just cut off when the last layer was. The nice part too is as long as you don't hit save profile, once you close Prusa, that script goes away, and the next print job's not going to be a fake temperature tower for you. So off to Cura we go. So Cura's here. Here we are. We're going to drag our model into it. It's going to take a second to open in Cura, which is fine, but we can see it brought it in okay. Here's our temperature tower. So the next step is going to be getting this tower sliced. Now, we're going to make sure that we have our layer height where we want to. So if you're in the default view of Cura, you can see up here where your little sliders are. So you can set it to 0.2 if you wanted. I also have other settings inside of Cura. So if you click the custom and then go quality, you can see what layer height is. So 0.2 is what we want. We're going to hit slice. We're just going to let this basically do its thing on this model because we want a few tidbits from this, especially if we're going at this fresh. So once it's sliced, you're going to hit preview. So you can use preview in the top tab or at the bottom corner there. And again, we're kind of going to do the same thing. We're going to look at the model. We're going to use the slider. And we know that the model is 557 tall. So that's 557 layers of print. So you can take a pen, you can take a pencil, whatever, and you can write down 557. If you're on your computer, you can actually look at it. That's fine too. So we're just going to take that. We're going to slide down now to basically our first layer where it ends. So here we come up and we're looking for that bridge again. Just going to rotate it. We'll zoom in. Let's see. That might be a good angle. So let's come up and we're going to look for that bridge. Straight right there-ish. And then there's the next layer. So I know that one layer before this, so 57, should be my sweet spot. Now, the fun part with Cura is getting it to play nice with you. So 56 is there. Can I get to 57 manually? I can. So 57 is good. If I type in 58 there, it's one too high. So 57 is our sweet spot. Now, if you want to know how to type in there, you just double click and you type. It's pretty sweet. So 57 is where our first layer ends. So we want to go up now into where our second layer ends. So it's right here. So let's go down. And I have 107. So let's go to 108. That's too many. So that's just double checking. And 107 is perfect. So now we kind of know our pattern. So it went from 57 to 107, which means it's 50 every time. So every time we want to switch layers, temperatures, it's 50. So now what we're going to do is we're going to go back to prepare just because. So now that you're back at the main window, we figured out our first layer change was at 57, and then we know it was 50 again, so 107. So those are important numbers. Just remember 57, 107, and I'm going to show you how to do it. So we click extensions, post-processing, and modify Gcode. In here, we clicked add script. Now we're doing the first one, change at Z experimental. It's been experimental forever. We're going to change at a layer height, a layer number. Now we want to make sure that we change the target layer and all subsequent layers. So that first option, if we don't do that, it's not going to set the temperature right for the rest of the layers, and it actually flips back to the temperature before. So make sure that's set. And then the other thing we're going to do is just change the extruder temperature here. So we know that the first change of temperature happens at layer 57. That's the last layer, 225, layer 58. Boom, would be the next layer. So let's go to layer 58, and we're going to set that temperature to 220. It's as simple as that. I'll do the next one, and then I'll do the rest off camera. But we're going to click add script. We're going to click change. So you see it just adds another one. We're going to do change at layer number. We're going to make sure that this is set to subsequent. before we even go up here, we know that it was 50 plus, right? We were 50 on our layer. So if we changed it at 58, because we knew that's where our layer temperature was, we'll go at 108 for our next one. So we're going to set 108, and our temperature, the first one would change to 220. So the next change is going to be 215 for the next subset. So now that's going to change it, and it'll go on and so forth. I know I said I would do the rest. I'll do one more. Add script, change at Z. We're going to do layer number. And this one, so we can look at our last one. It was 108, so we had 50. So that's 158 now. And that'll get us up into the next block. We want to make sure it's set to subsequent, which it generally is. And now we know that we did 215 last time. So now we're going to be on 210. So we have a change from 225 to 220, 215, and 210. And we can see as the temperature goes down 5 every time, the layer goes up 50 every time. So we started on 58 as our first change. So everything before that is going to print at the base temperature. So we need to make sure that we set our base temperature of our print job. Okie dokie. So they're all in there. Once they're in there, you can click close. It is important to remember in Cura, when you close Cura, it does not clear those scripts. So you have to come back in and clear them after you're done. So those are up in extensions. So there's this little wrench that appears down in the corner here, and it actually has your scripts. And if you click it, it opens the post-processing script wizard. You can shut them all off really easy. It's a reminder, so make sure you shut them off. Now, we have that done. The next thing we want to make sure of is that we do set our first layer temperature. It's easy to do. We just come to the material, and we make sure that it's set to 225. Which it is, and that means our first one will print properly, and then the post-processing scripts will change the rest. We hit slice, and after the slice process, we will save the file, or you can print it, whatever, but we're going to save it to disk. I'm going to save it just to my folder there, and once it saves, we'll take a quick look at the file. It's important to note that the Cura file and the Prusa file are going to be similar in the fact that it just puts those temperature changes in at every layer, but remember the Cura file will say slice by Cura and the layer is identified instead of layer Z. It has a little bit different of a label, but we'll take a look at this one and then I'll show you exactly what we're looking for on the temperature tower. So here is our sliced file from Cura. Now, here is where it sets our initial temperature. We're right at the top of the file. So line 16 says M104 225 S225, and it's going to wait. And that's what this M109 S225 means, is wait for the temperature, and then it'll move on after that. So what we're really curious to learn here is actually if it's changing at the layer we think it is. So I'm going to highlight layer 0. I'm copying that. We're going to go find. And we know that the first one we added in the change was 58. So let's look at layer 58. And you can see here, layer 58 has an M104 220. Changes the temperature to 220. That's perfect. That's what we want. So curiosity killed the cat. Let's see if layer 59 is set to 220. It should be. So look, layer 59, and oh, nothing's there, which means it is set to 220. So the next one was 50 more from 58. It was 108. So we'll just check this one for fun. And would you look at that? S215. We're changing the temperature at layer 108. So let's, again, just check in 109. And again, it didn't change, which means it stays changed until it changes again in 50 layers. So it works. Both of these scripts will do this. The difference is in the Prusa script, every time you see layer, it will set the layer temperature. So that script will always set the temperature of the layer when it starts. So it might not change it because it'll set it to the same thing, but it always sets it. But that's the big difference. So let's jump into our temperature tower and let me just show you what we're looking for, and then we'll wrap this up. So I just want to talk a little bit about what you're looking for on this model. So again, don't clean these up. Take them as they print. So you can see on mine, I printed a mini version. I started at 225 at the bottom and worked my way up. Now you can see I got significant stringing. See, wispy strings kind of on the bottom there. Visually, I can see them actually up to about this layer here. So the top layer is 210 and the bottom layer is 225. And you can see too that the little spires, so the spires represent cooling. So you can see that they're kind of deformed, and that one's deformed and this one's deformed. But then once I get up here, it starts actually getting straight. So at 210, it gets better. The other thing we're looking for is bridging. So there are bridging sections, and it's kind of hard to see on the camera, and I apologize, but the bridging section is obviously this section that runs along the top on every section. And you can kind of see that it's sagging, especially it's visible below 210 and below 215. It actually is sagging on the bottom one too, but the camera's getting a little low there. But it sags pretty bad until we get to about 210, and that's where it starts to get better. Now, this is an important thing. As you're doing these models, you might not get perfect, but if you get better, that's where you want to start printing at. So when it gets the best, and that's where it starts getting the best, that's where you print at. So we have bridging and we have a little bit of overhang happening. And you can see like on these ones, there's a little more droop happening. This one drooped up. This is because this was the last layer on this one. So the cooling on it wasn't quick enough. And again, that could be adjusted in the slicer. And this is what this model is designed to tell you. So there you have it. It's a temperature tower. Is it something that we print often? No, not really. Is it something we should print often? Maybe. I think the further along you get in your printing journey, you get used to the material and the material brand you print with, so you know what to expect. This can help, though. If you experience jamming in your nozzle, you can print one of these and see, oh, well, maybe it's because it's too hot, too cold, and you can figure that out. It can help you with stringing and little problems like that. So there are uses for it, but the biggest use that I found for it is when you switch to a, again, high quality material versus a low quality material, and you really want to see how hot you should be printing, and or how cool for that matter if it's a cheaper material. So if you made it this far, you guys are awesome. And hey, did you know we have a Patreon? It's patreon.com/3dmakeit. We'd like to thank Hal Johnson, our tree supporter, and all the other people showing up on the screen for showing your support. Without you guys, we couldn't do a lot of this video, so that's excellent, and thank you. If you guys want to give us a follow along on our podcast series, you can search 3D Make It on any of your podcasting apps and you will find us. Remember to hit that like, share, and subscribe button, and we will see you guys next time.